My name is Luke Jeffs. I'm the managing editor of Global Investor Group and Futures and Options World. I have been a financial journalist now for almost 20 years, writing for Euromoney, Thomson Reuters, News Corporation, Dow Jones, Financial News and other independent publishing houses. The industry has changed beyond recognition in the last 2 decades since I started reporting in the early days of financial technology. Electronic trading has emerged over that time as the dominant medium of execution, bringing with it unprecedented levels of access and transparency, but also new challenges such as achieving best execution and managing vast swathes of related data. Declining execution quality has been a key trend over the past decade, with market participants having to post more orders to get the required level of fills, creating uncertainty on the part of the trading strategy. What is interesting, however, is that relative to the development of the execution quality, it's posed challenges around data management. While technology has raced ahead in the front office in terms of speed and the sophistication of algorithms, analysis of execution performance remains a key area to develop to fully optimize trading efficiency. Today's webinar is divided into 4 main sections. The first 3 sections comprise some introductory comments from Stuart Farr, the president of Deltix, followed by demonstrations by Ilya Gorolik, the chief executive of Deltix. The 4th section is dedicated to questions and answers based on questions submitted by yourselves on the first 3 sections that we're going to discuss. Before we come to the first section, I'd like to invite Stuart to introduce himself. So, Stuart, if you would do that, please.
Sure. Thanks, Luke. I'm Stuart Farr, president of Deltix. Based in New York, I've been in financial technology for nearly 25 years, Luke, so I think I'd beat you there anyway. But my job today is to discuss the concepts of execution quality, which will be demonstrated by Ilya in the Deltix software.
This is Ilya. I've been working with Deltix for the last 10 years. I'm founder and CEO of Deltix. I would love to today demonstrate how new market by order and market by level formats impact execution quality.
Okay, thank you, Ilya. So we'll come to the differences between market by level and market by order in the 3rd section of our discussion today. But before we come to that, I'd like to invite Stuart to make some opening comments. And when we talk about execution quality, Stuart, what criteria define execution quality?
Sure. Well, it depends on the trading objectives, but execution quality criteria are typically the average execution price versus some benchmark, and that benchmark is typically arrival price or volume-weighted average price, that is VWAP. But particularly important in intraday systematic strategies, a key criteria is the average execution price versus the market price at signal generation time. That can be distinct from discretionary, but that's very important in intraday. Additional criteria are the time lag from sending the order to the execution and also the fill ratio.
Okay, thank you, Stuart. So I'd now like to invite Ilya to give us a demonstration of some of the solutions that Deltix provide to answer some of the issues that Stuart just discussed. So over to you, Ilya.
So the first part of my demo will be describing the application for execution analysis. So the user of this application, as you can see, runs in the browser, will click on command find orders, and the system presents the list of orders which were executed from start time to end time in a pretty straightforward format. On the left corner, where you can see my cursor, there's a benchmark. In this case, I selected arrival price, and every order is colored whether it's a better than arrival price, in which case it would be green, and if it's worse than arrival price, it would be red. Specifically, we're showing the price improvements in ticks and in amounts, and definitely, as Stuart suggested, when order was submitted, order was filled, how long does it take? So let's just look at one particular order. Let's just say select the order 5,077.47. What we see when I drill down in this order is the following. The gray line represents the mid price of the security, in this case is the crude oil. And triangles represent the child orders which were executed. In this case, it was some kind of proprietary TVAP kind of algo which is developed by a broker. And if I click on execution details, we'll see the sizes of child orders and field prices. Now, the green or red line represents the actual cost of execution. And we see that at the end of the full order execution, the execution price was 28.56. And arrival price, as we see in this line, horizontal line representing, is 28.615, therefore we're worse than arrival price. If I change the benchmark and literally say that I would like to look at a VWAP, then we see the VWAP price represented in the background in a gray kind of a volume area, and our execution price in this case is better than VWAP. And as the report says, we're 2 ticks above VWAP price. This particular drill down also allows us to look at the volume profile, as you can see in the pad below the price where my cursor is, the gray area with volumes, our volumes relative to market volumes, and execution sizes. What else we can do? We can show the execution statistics by selecting, for example, the histogram control. And when I click at any place in the screen, we will be looking at group of orders. So for example, in this particular group of orders, all which I selected in this zoom box represented at the bottom. And finally, we're also allowing people to look at, for example, scatter plots, which in this case, I would like to look at dependency between execution size and price improvements in ticks. And again, every order follows the color schema. Green means it's a better than a benchmark, and red is a worse. And if I change a benchmark at any point in time, system immediately recalculates itself. So that's the overview of a system that enables to look at execution quality and measure it relative to benchmark based upon criteria of field price. Thank you.
So we now move on to the second section of the presentation, which is looking at prerequisites for measuring and managing execution quality. So, Stuart, if I could come back to you, please. What specifically are the prerequisites for measuring and managing execution quality?
Sure. The key prerequisite is a data repository to record all your orders, executions, together with market data, of course, the market data being the set of quotes and trades from the exchange. Now, it's very important that this data is recorded with synchronized and consistent timestamps. And ideally, the repository should be sourced from your production trading environment. So in that way, your research and trading environments share the same latencies and idiosyncrasies that are baked into all infrastructure setups. Very important. So typically our clients will take a copy of their production trader, again, of their orders, executions, and market data, and move it into a dedicated research environment. But it's still the same data as production with the same timestamps.
Okay, thank you, Stuart. So now if we could go back to Ilya, who is going to give us another demonstration based on some of the things that Stuart just said. Ilya, over to you again, please.
Thank you. So what we see in my screen is that we open the remote desktop to our Cermak server, and we will see how real-time quotes are streamed to Timebase. Let's just examine what we see on the screen. On the left top corner, where you can see selected contracts, it's the instruments which I just highlight in this particular monitor, which is in the biggest window on the screen. And this monitor reflects 10, as I selected this number, last updates to any particular instrument, which just happened in real time. Obviously, the most important columns here are related to market data, starting from timestamps. So the time with millisecond precision column represents the actual time when message arrived on the server. And the market message time represents the timestamp from exchange. And that basically gives us a lot of information about your particular structure of networks and your network switches, your connectivity, your gaps, and so on and so forth. The rest is also pretty clear. Trade message shows the last trade with size and aggressor, side, buy, sell, the volume, and then we're coming to level 2 messages, which were presented. I just selected a few columns where we look at the level, depth, and update, delete, insert, actions, and basically number of orders. So all this information is available in real time. So if I just choose any instrument, we will see definitely live any updates from this particular instrument. And this whole information in historical times kind of perspective represented right here. So let's go and look at exactly this level 2 data, standard market by level, stored in time base from, in this particular case, November 18th of 2014. So this stream has more information than one I show you on the screen. It's just visible. It's just a lot of columns. But this is otherwise the same exact information where we see the snapshots, which you can see right now, different levels, and level 2 messages, which are presented in the form of update, delete, insert actions at the different levels. Visually, this information actually looks pretty cool. If I switch to charts, then we look at 2 contracts, crude oil and the minis, and the blue crosses represent trade messages, and 10 level of asks and 10 levels of bids represented below in the form of a band. So that's the information about order book being aggregated, collected in time base from real time. That kind of explains the prerequisite number 1, which is the accurate and detailed aggregation of market data. Thank you.
Okay, thank you, Ilya. We'd now like to move on to the third section, which is looking at CME's new MBO data. So, Stuart, if I could go back to you, please. Could you please talk to us about the relevance of the new CME MBO data set, please?
Certainly. Firstly, I'd like to just thank Quant House. They provided us with the CME data that we used in the research that Ilya is showing you, so thanks for that. In a moment, I will summarize the characteristics of both the MBL and the MBO data. And as you will then see in Ilya's demonstration, the key point of these differences is that the MBO data allows full transparency into the exchange order book. Now, in so doing, it allows the ultimate precision in both the analysis of actual executions and, very importantly, the simulations of limit orders submitted using various execution methodologies, including, of course, execution algos. But to the differences, market by level, or MBL, is sometimes known or is also known as market by price. This is the historical and current format used by the CME and other exchanges as well, of course. MBL data provides the price and quantity at the price at each price level, and you get up to 10 levels of bids and 10 levels of offers in that structure. Now, in MBL format, the trader can only identify his price level, not where his order is in the queue. Now, if we turn to market by order, that is MBO data, just for the equities people amongst you, this is, as you may know, this is sometimes known as level 3 data, particularly in the equities world. But CME made MBO data available towards the end of 2006. Previously, only market by level MBL data was available. And they've been rolling out product by product and starting with COMEX and NYMEX. And in the demo, you'll see Ilya use gold and silver and crude. But the key point with MBO is that it shows the individual order sizes that make up the total quantity at a price, including, and very importantly, including their priority in the queue. So as such, there's no limit to the number of levels that you can see. And again, you'll see that in Ilya's demo. And also, very importantly, each order has an order ID or a quote ID, which is known only to the trader that sent it. So therefore, the trader can identify his order in the order book. That is his precise position in the queue.
Thank you, Stuart. So, Ilya, would you like to show us some of that, please?
Definitely. Thank you very much. So this is going to be the most exciting and probably the longest part of our demonstration. So we'll start from exactly where Stuart said. Let's look at formats. Let's look at difference between MBL, which is market by level, and market by order representation. We have data from Quant House. Thanks for them for the offer. And 2 days of market represented right in these two streams. First stream is market by level. If I click on the first message, where we're just basically getting information that new offer was submitted, and I click on this message, we're seeing that we got insert right at the top of the book, which is basically bid, and the price, and the size, and this number of orders. That's all we got at this point, information about the level. If we switch to exactly the same information in market by order format, exactly the same message would represent as, yes, we submitted to the top of the book, exactly the same price, order with quote. Quote ID here is just a large number, but you can see this quote ID. And that has a huge impact because now we can trace exactly this order and understand everything about this order relative to its peers. So any message in the MBO format has always supplies a level, of course, action, and the quote ID. So we have, for example, a limited amount of orders, levels. This is level 23, and so on and so forth. Unlike MBL format, where the amount of levels are limited to 10. Now, what does exactly it means? Let's look at the following. We created, using the MBO format, from this format, we've created 2 streams, 20 level deep, 30 level deep, and we obviously have original standard market by level format. So if I click on this instrument and go to the chart, we see the similar picture I showed you before, where trade messages, blue crosses, have 10 levels of asks and bids. Click on this, and we see 20 levels. You can see definitely wider book, and I click on that stream, and we see now dense 30 levels deep. So we can basically go and see the size of the book. Obviously, this picture represents significantly more information than this one. If I click on the entire book, it will be useless because it's going to be hundreds of levels, and so, just can show you, but it's not really that useful. So we're going to use this now representation of market by order to make some pretty insightful observations into the market microstructure. We'll start from using our tool called Quant Office. And in Quant Office, we'll start from running a very simple strategy called Order Tracker. This particular strategy, I'll click on Command Run and explain what it does. So let's click on Command Start. This particular strategy will track only one order, which we will be submitting one contract to the top of the book. We're buying at February 20th at 12:27 a.m. That's all we're going to do. And if I click on Command OK, the strategy will start at work. And in the interest of time, I'll just close it, and I'll show the results of the strategy, which I already simulated before. So this picture represents the order book and basically standard supply-demand kind of curves, which is number of asks and number of bids at any point, but the value of this particular strategy is in this report. Let me just bring this report, and we'll have good time with it. So this particular report has 7 columns. The first column is a timestamp, just literally, just timestamp, as we know we submit order at exactly this time. Then we've got column with MBO action, market by order action. Just describes exactly what took place in market by order format. Next column is exactly the same mirroring information in market by level format. So we can literally see how one action compared to the exactly same action expressed in different format. Next one is a very interesting column. It's a basically kind of character-based snapshot of order book, which we're going to talk in a few seconds what it's all about. And then in market by order format, exactly the same is the market by level format. And to be brutally precise, we're tracking how many orders are ahead of us in the book in two representations. So we got pretty deep an understanding of what's happening with the book. Now I'm choosing layout, and I'll apply the special layout I created, which will give us an abstracted view of all this information. So let's start from the very beginning. So in the beginning, when we submit our order, we're seeing that our order is marked is @1. This is our order. We can literally see how it moves in the book. And in the beginning, in both formats, we see that we've got 14 contracts ahead of us in MBO representation, exactly 14, just broken into sequence of 1, 1, 1, 1, 2, 1, 1. If you add them all together, I'm sure we're going to get 14. And then we get an action that one order was placed in the book, and we're placing it behind us because exactly MBL tells us where it's been placed. So it's at place 15, and it's behind us. So we can track exactly the same representation in MBL format. So far, there's no difference. However, if we see some commands our orders get deleted, let's say, for example, this bid was deleted, and it specifically defines where it was deleted. Very important part of the demo also, I'd like to show the following, that you can see the new level was added. So at this point, the new price, better bid was added, and so our entire queue was shifted to second level. So the format in this kind of a textual representation shows that PX defines level. You can see at the bottom new levels arriving, and the queue entire representation of all levels of all orders would be just represented in the form of characters. So let's just look at something which I want to highlight. Right here, this line, where we get command saying that, let's go to compare MBL format with MBO format. Right here, system says that we're going to delete at 18th place this price, this order. And we know, based upon all this information, exact location of this delete, and market by order format, it's easy to count 18 spots, and we marked it exactly here. So we deleted order in front of our contract, in front of our submission, right here, -1 in red, and @1 represents exactly this action. However, with market by level representation, we can't make this assumption. This message, update, we know that size of level changed, but we can't make assumption that this order was ahead of us, and therefore we take pessimistic. And we could take a kind of realistic simulation, and we're saying that, yes, we will be deleting this order behind us. So let's see the difference. In market by order representation, we've got 22 contracts ahead of us because we know it for sure, and 5 behind us. In market by level, it's quite opposite. We've got 14 ahead of us because we can't, and 5, and yes, we got 14 ahead of us and 4 behind us because we just basically, here we got 15 and 4, 14 and 5, and here we got, sorry, I just confused, but it's clear what I'm saying. All right, this line, yes, my apologies. So we simulated the information. There's a 5 behind us and 4 in this particular line. That precise or basically information gives us opportunity to track entire flow of this order. If I scroll down, we can see the life cycle of the entire book, and we visually can literally see everything as it happens, which means at the bottom, last few lines are also pretty interesting. So the state of the book before the order was filled, that in MB market by order format, we got 6 contracts ahead of our order, while in market by level, we got 9 contracts. We got a message. The trade was executed 7 contracts, which exactly means that our order was filled plus actually order behind us with MBO format. With MBL, situation is different. We still have 2 orders ahead of us, and only subsequent updates to order book eventually fill this order. So we definitely can see how simulation by MBO, market by order, will be different from market by level. So that's kind of the literally just a close view to the order book. And to illustrate the significance of that information, we created one very useful strategy, which tracks placement of the order, specific order from by ID in the book relative to best bid, best offer level. Let me run the strategy. So what we'll do, I'll just track two orders, basically 4114 and 4274, and just click backtest, and I'll show you this pretty interesting chart. So let's look at this chart. It's actually a very unusual chart because we are measuring not the actual price level, we're measuring the distance between our order or any order measured either in an amount of orders prior to us or in the amount of sizes at the bottom chart. And let's just zoom in and see what actually this chart represents. So every line, like this red line, represents the first level. How many contracts? Let me zoom into this particular area. The 0 represents the top of the book, and the first level represents how many contracts, how many orders, actually, I'm sorry, in this chart, how many orders in this level. There's one order in the beginning, then it goes to 2, the top of the book. Next line is a level 1, level 2, level 3, level 4, and so on and so forth. So when we place our order, for example, the top one, I placed it right at the top of the book, right here, and the bottom order I placed at the top of the book, second order I placed at the 5th level. And we can see how it moves relative to the top of the book. What's the distance between this order and top of the book, because we know exactly this order ID. And this order got filled right here eventually because of other update, delete, insert messages which took place. So that representation gives us a pretty cool view of the life cycle of the order in the context of its place in the queue. And in the bottom chart, we do exactly the same information, except we just measured an absolute amount of contracts as opposed to amount of orders. We also see that to compare market by order with market by level executions, it will be very useful to write a massive experiment set and submit limit orders into the book and look at the execution. So we wrote a very kind of simple strategy. However, we're going to deploy it on the cloud because we're running massive amount of experiments. So Deltix has developed a new product, which we call cloud-based backtesting system. And I'd like to demonstrate it, how it works. So this particular strategy, which we're going to simulate in the cloud, I'll explain in a few seconds what exactly it does. So I click on Command Run, and we will do the following. We will submit every 10 seconds limit order for these three instruments, for crude oil, for gold, and for silver, using basically two form simulations, market by level, market by order. And this limit order, if it's not filled within a certain amount of time, will be converted to market order. So this particular alga is a limit which instead of cancellation, we'll just simply fill it by market using mid price as a fill price. And I'll run 8 experiments on this cloud using 5, 10, 15, 20, 25, 30, so on and so forth minutes as a time when if we don't fill the order, it will be converted to market order. Configuration of our cloud is right here. We've got 2 instances of the boxes. We've got 3 computers for standard, and I'm going to run this configuration, which I like, 16 CPUs. And with that, let me go to experiment plan. And so here we tell system that we're going to split it among different cloud boxes, totally 12 cores. I'll name my experiment. Just let's call it webinar 8, and I click command run. So we're seeing right now the system being deployed live. Literally, as we see it, it's just going to perform. It says that it utilizes 8 CPUs, and will start its calculations. And we will be tracing how many messages it processes, how long does it take to process. We will process, I already know, around 5 million messages, and the instant message rate right now is like around 150,000 messages per second, which is requires special explanation, which we'll do later, because typically this is measured in millions. However, simulation of order book in 2 formats is definitely time-consuming and very expensive procedure. Still, we're going to generate around 100,000 orders for our experiments, which we're going to do in a few seconds. So we can see right now that some CPUs are getting released. That means tasks are getting close. We're done. We calculated all this information, and I click on command done. We're getting to this report. Let's look at this report. It's actually 100,000 rows. Right here, you can see my cursor at the bottom. Everywhere where I'm going to click, this is going to be update, and we're going to manipulate this report in the cloud. Let's just look at some important information. So there's 2 questions we want to ask ourselves. What's the difference between, to qualify the difference between market by level and market by order execution, there's 2 things we'd like to ask. How long does it take to fill the order using market by order simulation versus how long does it take to fill the same order using market by level? And what's the price where we fill this order? As we can see, there's multiple states. There's a fill order can be filled or canceled. And when market by order is get canceled, that's interesting for us because we know already that market by level will be also canceled. So we're going to keep filter. We filtered 30,000 orders where market by order is filled. And now let's run simulation of comparison. The first thing I'd like to ask, and I'll go to scatter plot, and I'll ask a question. Does it make a difference in time? So by x-axis, I'll choose the MBO time to fill, and by y-axis, I'll choose MBL time to fill. And we immediately see this pretty cool looking scatter plot, which shows us that under no circumstances MBO time to fill is greater than MBL time to fill. You can see that it's all strictly above. If I drill down by experiments, which basically mean how long we wait to fill the order, we can see it in seconds, 300 seconds for MBO, 300 seconds for MBL, and we look at majority of orders, if I click on any of the cells, would be exactly the same. However, some orders, like for example this one, this group of orders for this instruments, in MBO format, took us only a few seconds to fill. Let me just show you this column where my cursor is. MBO time to fill for the first order is 36 seconds. For the first order MBL time to fill is almost 300 seconds. So we can see the differences, partially because orders get canceled, partially they get filled at the different assumptions. And if I start adding experiments, we can see how this diagram, histogram, or actually scatter plot moves to the right. It also basically explains the full situation. So that's the kind of number one case, which shows us that MBO, or market by order, orders fill faster than market by level without any exceptions. And the second use case, which I'd like to show you, is what happened in terms of field price. So the only difference, because the algo which we use is very simple algo. We're submitting the limit order and converting it to market if it's not filled. So there's not so much differences between MBO and MBL. However, there will be some use cases when market by order is filled, but market by level will be canceled. Let me just quickly illustrate it. I type here canceled and click on apply. And we see 810 use cases. Around 1%, a little less than 1%, where we have complete difference between status of these orders. Even if it happened to be a child order, that's pretty significant, because if you submit a large complex alga where a child order will behave differently, that will impact the full execution of the entire alga, which is definitely not a small thing. Even though it's only 1%, if you stumble across this difference, it will be a pretty big impact for your simulation. And so the last piece of my demo, just want to show you distribution of differences in fuel prices between MBO and MBL. And this histogram has a lot of, obviously, common sense. It shows that in most cases, if in terms of, for example, frequency, in around 85% of cases, specifically 75.6%, they're pretty much identical difference. But however, there are some cases where MBO and MBL has a pretty large difference in fuel prices. Well, that was my kind of demo of simple but hopefully useful examples illustrating how market by order and market by level simulations can bring different results.
Thank you, Ilya. So we're now going to move towards the last section of today's webinar, taking some of the questions that you've been sending in. We've had many. One obvious question that jumps out, it's quite a simple one. In the demonstration that Ilya was doing, are we talking specifically about orders, or are we talking about lots?
Yes, it's Stuart speaking. I'll just say something, then Ilya will demonstrate this with the first bit that he showed on the strategy. You know your order in the queue. All orders are in MBO format. All orders in the market are explicit. In other words, they're not aggregated by price. They're all explicit. So you know order by order what the queue is, and also within each order, you know the quantity of contracts or the number of lots in that order. So you know both, in other words. So Ilya, I don't know whether you can just go back to the first part of the MBO, MBL comparison and just walk through that textual display of orders in the MBO book, pointing out the orders and then the number of contracts in those orders.
Sure, give me 1 second. We can do it in both cases. This chart definitely shows both. In the bottom, you see lots. At the top, you see amount of orders. So that's kind of representation, graphical one. And unfortunately, I guess I deleted my spreadsheet, which showed the textual representation. But basically, if you remember, in the queue, we had numbers 112, 111. That's exactly the size of the contract in lots. So you can definitely calculate it as well.
Thank you, Ilya. Another question. Can you aggregate passive versus aggressive executions?
Yeah, so this was a question that came up during the demonstration of the execution analytics tool, or TCA as it's sometimes known. We didn't show it in there. Rather than show it again to say yes to that question, I would add that the definition of aggressive and passive is sort of obvious, but to some extent subjective. But either way, we can aggregate by whatever your definition is of passive and aggressive.
Okay, thank you, Stuart. Another question. What advanced tools do you have for the analysis of the dynamics of the order book and the price action?
That is essentially what Ilya's been showing, other than the last tool, is QuantOffice, which is the standard analytical package we've had for a while now. So it's deep analysis within that, but the tool is QuantOffice. And what you can do in that is what Ilya showed you, amongst other things.
Well, let me add a couple more things to this question. So the set of tools, actually, which we have, starting from Timebase. Before we go to QuantOffice, the very advanced tool called Timebase, which allows to store all the messages, define custom streams, define custom analytic, and write actual applications, not only in QuantOffice, but in other languages. So the lowest level kind of denominator is called Timebase. Then, of course, there's QuantOffice, which integrated Timebase at the level of messaging APIs, and it's a .NET environment, which you can basically use also languages like Python and R. And finally, we just build a cloud-based infrastructure, which allows to produce experiments which will be requiring hundreds, if not billions of messages. We can run them very fast. We have a benchmark where we run 500 million messages per second today. We can run billion tomorrow. It's not a problem. So this is a wide spectrum of tools, but starting from Timebase going to analytical layers.
Okay, thank you, Ilya. Another quick question. Is MBO going to be rolled out to the E-mini?
That's a great question. So, I mean, that's really a question to the CME. It's not right now is the short answer to that question, but what people can do is go to the CME Group website, and they have a very clear chart of the rollout of MBO according to various products and markets that they have. And E-mini is mentioned on there, but I just go to there directly and then I won't misinterpret it. So CME Group, type in MBO and you'll find it all explained there.
Okay, thank you, Stuart. Another question. Is MBO data available on the same or a different CME feed from MBP?
Oh, that's a good question. So it's the same feed. The CME have done a good job. You don't have to subscribe to another feed. It's the same feed. You still have to handle the data, of course. That's a separate discussion, but it's the same feed.
And is there any change in volume of market data between MBL and MBO?
That's related to the previous one, but yeah, absolutely there is. And I'll just say that. And Ilya, I think that's probably a good opportunity for you to show some of the volumetrics that we have. There is an increase, Ilya. I can show you that in one of the tools.
So what I'd like to do is use this tool called Performance Meter, which will be also counting the messages. So if I tell system, let's calculate how many messages we got in MBO stream, we'll quickly run it. This particular, it's not a big test. We're running around 1 million times per second. And so our exactly the same 2.5 days of recorded market in MBO format has 6.9 million messages. And exactly the same data, if we go to MBO format and I click on start command, will be around 5.6, 5.7 million. So we can see 30% basically informational high capacity of MBO versus MBL.
Just to comment on that, that's for those contracts that Ilya's showing there, the crude, silver and gold. Obviously, more liquid contracts will have higher volume, may have a difference between MBL and MBO data. We'll, frankly have to see.
Okay, thank you. One more question. How do you measure the order size impact to the price move?
Yeah, market impact is literally a webinar in its own right. So suffice to say, you have the ability here to define your own model. In other words, you can make your own assumptions within the tool on order impact. There is no one general theory on market impact. There are several theories and several ways that people measure that. So we don't say this is the way you measure market impact. We allow you to put in your own assumptions for that.
Okay, thank you. Just a final question. We're coming up to time now. You mentioned time synchronization of market data and orders. Can you just talk some more about that, please?
Yes, I did. The concept here is to do this analysis, you need to be capturing in the same place the market data that we've just spent time looking at, as well as your own orders and execution of those orders. So they're essentially coming from two different systems. They're coming from the exchange and the exchange feed, and they're coming from whatever system that you're executing through. So that immediately raises the prospect of having different timestamps. And so it's important to avoid that and have time synchronization of the clocks such that the timestamps that you attach to all of those data sets are synchronized.
Okay, thank you, Stuart. I think we're coming up to time now, so we should probably think about wrapping up. Feel free to contact Deltix on the email address that was showing on the webinar homepage. So just finally, I'd like to thank Stuart and Ilya for all of your contributions and to the audience for all your attention and questions. Thank you.